To demonstrate the bright line emission spectra emitted by atoms in the excited state, we have a spectroscope. The eyepiece has a very thin piece of plastic film. The plastic film has over 25,000 scratches on it per inch and acts as a prism, breaking the light into its component parts. When we look through the eyepiece, focusing the light in the slit, we're able to see, with white light, a continuous spectrum. Let's do that now. As we look through the eyepiece, we can see the continuous spectrum emitted by the white light. White light contains all frequencies and wavelengths. Here we have a high voltage supply in which several thousand volts will be passed through this neon tube. These gas tubes are evacuated and filled with a gas. Here we see neon in the ground state. When we turn on the high voltage, we see it in the excited state. Here's the characteristic orangish glow of the neon tube. Once again, we can look through the spectroscope and see the bright line emission spectra of neon. As we look through the bright line spectra, we can see some rather surprising colors. Who would have thought that in that red-orange there are bright green lines? However, neon contains 10 electrons, and in the early study of the atom, they wanted a simpler atom, and so they got the simplest atom to study, that of hydrogen. Let's replace the neon tube with a hydrogen tube. When we turn on the hydrogen tube, we again go from the ground state to the excited state. Here the color is a little dimmer, and with only one electron moving, we would predict and expect to see fewer spectral lines. And as we look through the spectroscope, we see that that's true. In the visible spectrum, hydrogen has 4 spectral lines.